It's day 22 of Advent of Code, and today we are doing Monkey Market. And the Monkey Market is a very interesting place where each buyer has a secret number that evolves over time, and each time it goes through this weird process where it's multiplied by 64, then mixed, and then pruned. And then it's divided by 32, then mixed and then pruned, and finally multiplied by 2048, and then mixed and pruned again. And this mixing and pruning has these rules. It's mixing is bitwise XOR, and then pruning is dividing by or modulating by this huge number. And basically, this is what happens every single time. So when the buyer starts with this number, it evolves like this. And we, as an input, are given secret numbers for each buyer. And we need to figure out what happens after 2000 of these steps. So you can see that the result will look like this, for example. So our goal is to figure out the sum of the 2000th secret number generated by each of the buyers that are in the puzzle input, which is kind of long. So it's not a short one this time. So let's see what happens. So I will start with the sample input first and put it here. And then we'll go and try to solve this. So first I'll have private, let's start with ulongs maybe, because it's gonna be, the numbers are not going to be small, and summing them all up will be also large. So I will go with ulongs immediately. So let's implement first the mix method. So mix going to be ulong A, ulong B is going to be bitwise XOR of the number and the secret number. So A XOR B, private ulong prune will be long A, and that's going to be A modulo by this, A modulo by this number. And then we do, then we have the rules themselves. So evolve secret, ulong secret number, and step number. So this step number will tell us what we actually have to do, because it changes in the sequence. The question is this done every time, this whole thing, or is it one step, second step, third step? We'll see. We'll try to do it at once, and we'll see if that works for 1, 2, 3. But so we'll multiply by 64. 64. Then we mix secret number, then we prune the secret number. What is it complaining about? Yeah, because it's okay. So it's okay. So we have to. Okay, we have to multiple. We mix with the multiple. Then we have prune. Then we have the second step, which is calculate the result dividing by a secret number by 32. Right. Secret number divided by 32. Then we round the result down to the nearest integer, which is done by dividing directly. and then mix into the secret number. So secret number t mix and prune. And finally, we will do multiply by 2048. So multiple 2048, 48, and then we mix it and prune it. Okay, so that's done. And then we can check if it's actually working. So I'll keep it without the step for now. I'm not sure if it's going to be needed in the end. So secret number. And we will try to see if, what happens for the test data. So for each, well, long sum can be this. For each number, we'll do parse it and then do for 1 to 2000, we'll do secret number equals evolve secret number. And after 2000 times, we will get the number, find the final number, and we will add it to the sum. And we return sum to string. So that's about it. And let's see if the result is as we expect it to be. So right, so we have the app is launching. Let's do 22. And the first number is 1. And yeah, so we'll see what happens after it runs 2000 times. So secret number is 86 something. Yes, 8685. Yes, seems okay. So let's see what is this final result. This number. Let's see if it's actually correct. Oh, too low. Okay. Too low. Oh, because I'm testing with the test data, not the real data. But we can see if the result is matching. Yes, it's matching the sample input. So I will try the full input now. Let's see if that is going to work. So the result is the following, and yeah, you have to wait. So, but seems promising. I don't see any problematic thing about this part of the problem. So let's wait for it. Okay, so it's correct. Now let's do the second part. So in the second part, we are given instead of the prices, we are using the digits from each secret number. So we are using the digit 3, 0, 6, and so on. So the last digit is the only one that's interesting for us. And we are looking for okay. So we have actually a monkey that is looking for 4 consecutive changes in price, and then immediately sells when it sees that sequence. So if you start with 123, the secret numbers and changes are the following. And the first 6 that's in the sequence appears only after 2 changes, so the monkey doesn't know when to sell, but after changes -1, -1, 0, 2, we get another 6. So if we tell it to sell at this after these changes, then it gets the best price. So if the monkey never hears the sequence, then it never sells. And we can give the monkey only a single sequence of 4 price changes to look for. And we are always looking only for the first occurrence of those 4 numbers. So if it appears multiple times, we just get the first one. And our goal is to, to get the maximum possible number of bananas. So we need to find the sequence that will get us the best result across all the numbers in the input. So, okay. Let's put it here. And let's try to implement that. So I'll take the existing implementation, just adjust the naming here, and let's do this. So private int digit number. So this will get us the last digit of the number. So modulo by 10, we get the last digit of the number. And this will be useful because we will be trying to figure out what are the diffs between the last digits. So we'll have some kind of, let's create a private dictionary of string to int. So sequence sums. So this dictionary will hold the sums for individual sequences across all the numbers. And then we have current sums. This will be just for the current secret number that we are processing. So every time we evolve the secret number, we'll have a link to this as well. So last diffs linked list of int. Once we evolve a number, we'll get the diff. So new secret number. Then we do secret number equals new secret number. We have the diff. So this is going to be the difference between the two numbers. Let's do longs then. So long, or rather, let's just replace everywhere long with long here. Okay. So hopefully it's going to be enough. And then we get the diff between the two numbers. and turn it into int. It should be fine. And then we get, oh, right. We need to actually get the last digit and last digit equals this. So we are working with just the last digit, so we can actually keep longs, keep with ulongs, and we can take the diff between new last digit and last digit. That's the diff that we are looking for. So last digit and new last digit, and we then just replace new last digit with last digit. Last digit with new last digit. Or previous last digit with new last digit, and then we get the diff and we store the diff. So so we add it to the end of our list of last diffs. And if the count is equal to 4, if you have at least 4 diffs, we will be removing the first one, but we will also get a diff string, which will be last diffs select. Yes, exactly. Select the digits, and we'll join them with a string. So let's do string join, and we'll do this, something like this. So we'll create a string that will be those diffs connected by commas, and that then we will look if we already have that in the current sums. So if current sums, not current sums, contains if string, if we don't have it yet, we will put there the if we don't have it yet, if we don't have that diff string yet, we will have to add the next last digit. So get last digit of new secret number of evolve new secret number. So we will evolve the secret number and get the new digit there. So we evolve it because we need the next one, and then sell. The question is if we 2000 price changes. So the question is if we also can buy the 2001st one, but for now let's keep it like this, but it might have to be like 1099, but we will not 1999. So, but we'll see. So for now, let's keep this, and now we add it to the current sum. So if we didn't yet encounter this sequence of diffs, and then continue. And finally, when we're done with this specific number, we'll no longer sum this. When we're done, we will go through for each in the current sum. We will see if it doesn't contain the key. Otherwise, we add it to the value. So sequence sums equals key plus equals value. So we add our current sum, our current number to the sequence sums. That's across all the numbers, and then finally we find the largest number. So sequence sums values max is the result that we are looking for. Hopefully that should be it. This is the input. So for this sample input, we should get the sequence -2, 1, and -1, 3, and it should be 23 bananas. 24 bananas, that's interesting. So we're one off there. So let's see if we can fix it by doing this. It should hopefully be it. 24 still. Okay, so there is something wrong there. So let's find so max bananas will be this. So sequence sums where key value equals max bananas, select and key first. So let's see which one is the one that we're getting there. Not sure if this will work. So 1 minus 3, 5, 1. Okay, so that's not what we are expecting. So okay, let's see what happens. Let's try to simulate this a little bit. So I will do the 1, 2, 3 here, just to verify my logic is actually working correctly. So let's do this one. It's going to be the input file here. So that is 1, 2, 3. So we should be getting sequence of 0 and -3. So let's put it here. 0 is the last digit. -3 is the diff. So last diffs -3. So ideally here, we should be now getting the first entries. So last diffs should be looking like 6 minus 1 minus 1, 0. And we should have it there, -3, 6, -1, -1. So -3, 6, -1, -1, it's going to be 4. Now we're going to be adding 6. Oh, okay. So we're adding the wrong one. So we're selling the same number, the same last digit that we are getting. So this one is the one that we are selling here. So that was the difference. So let's try the big input or the sample input first. I misunderstood the logic there. So when we sell, it's the same number that gave us that current difference. So -2, 1, -3, 3. Yes, that's better. So now we should be getting the right result there as well. So let me check here. The value of max bananas is 23. Okay, that's good. So we can remove this and just do return to string, and we should be done. .23 and input file is here, so it's running, and it's 1910. And that is correct. Okay, so we're done with day 22 of Advent of Code. Right, so there is just 3 more days left. I will also make a video to see if ChatGPT can solve this one. It seems like it's not a hard one, so maybe it will be able to. And yeah, I will see you in the next one.